Hey everyone, I'm gonna talk about how to create effects based on position, either local or world position of the object, of the pixel. And yeah, let's go. Let's open this wall paint stuff. So basically, first thing, how do you read position in a shader? Let me close Blender, it's not needed. To read position in a shader, you do position. And there are a couple different coordinates. You have local position, world position, and screen position. What's the difference? So, world position is the actual position of the pixel in world coordinates. So no matter the rotation or movement of the object, it will always get you the actual meters from the world center. So let's try that. As I said in the previous stream about essential math operators, when you do a frac, it will always give you the fractional part of the number. So if I divide it by 100, centimeters other, right, thanks. So word position gives you position in centimeters from the word center. So word position, we divide it by 100 to get meters. Okay, this is position in meters. Now, when I do frac, I will have like the modulo of it. You will see it. Frac, like so, connected to color. Apply. This is what will happen. The stuff. Okay. So basically, it's the position in now in meters because I divided by 100 and just repeat it because of this frac node. If I didn't have this frac node, the values would be very big, so not entirely useful for visualization. As you can see, yeah. So blue is of course Z up, green is Y, and red is X. This is what I mentioned on the previous stream. So about basics of vectors and visualizing vectors as colors. So basically RGB represents X, Y, Z. And here is my X, Y, Z in meters, but values are too high, they are clamped at 1. So when I do frac, I can at least see it repeating. It's better visible in unlit mode, like so. Okay, this shows me basically where I have my cells of 1 meter. Now, this is world position. So when I move that, hi old siren, how are you? I hope you learn useful stuff here. When I move it, see what happens. The colors stay in place. They stay in place because I read word position, absolute word position. Now, what if I wanted position inside the object, sticking to the object? I should replace that with local position. Local position is a function. You can use that. It's okay, but I will show you how it works. Similar, right? But now, when I move it, it moves together with my object. Like so. It's a local position, so from the pivot of this object and excluding rotations. So, wait a sec. Control space, something different now. As you can see, I will disable snapping. As you can see, rotating the object makes the local positions still stay connected to it. It's really local, like in the imported mesh. Okay, rotating the entire thing, while word position is actually like so. It's sticking to the word, not caring about the object. Word position is perfect if you want to unify stuff between many objects. For example, I will talk about it more in the future because I plan to have a stream about generating UV coordinates and triplanar mapping and so on. But just to give you an example, if you were to have a texture that's continuous between multiple objects, then these word positions will serve as perfect UVs. Because if I copy, let's say, this object, can you see what happens? The cells are aligned to the word space. They don't care about the object. So this is awesome for making things coherent. Now, could you please show what's inside this local position function? Let me first guess that this would be a transform. Because we have a transform node, and basically, this is hard to explain, but very important, I think. Vectors are only have a meaning within certain spaces. This is one example. You can't just say position. It's position in world space or position in the local space of the mesh. When the mesh is rotated, its local space is, rotated as well with it in the word terms, but relatively it stays the same. Inside the object, nothing has happened when the object rotates. Only when it's placed in the world, you can see it being rotated. So transform function converts from space to space. For example, word position can be converted to from word space to destination local space, for example. Okay, and this allows you to to get the if you want to get some information from the world, let's say, into the object. This is more important when some things are out of your control. For example, parameters or some other transformations. Inside this, we have a transformation from word position to local space. So basically it gets word position because that's the actual node, the red node, and then it has to transform it because it doesn't have any local position node, so it transforms it back into local space and just outputs it. Transformations, very useful. Old Siren says, things being out of control sounds like my life. Mine too. Mine too. Especially since leading the Stackers team is like, I don't know. I don't know what's going on. But I hope you can manage it, learn it to manage it at some point. But I'm trying all my adult life so far and no luck. So I'm not sure. Or maybe the chaos is the way to go. Just ride the wave. Exactly. Just ride the wave. That puts it in the better light. Thank you. Here we have our word position. Brilliant. So we can have a mask that will be independent of the objects. We can have, let's say, clone of our object, and we want a mask that will be the same between those. So let's say a dirt going from the ground up. First, when it comes to spaces, I also need some point of reference. What's the origin? Origin of the word is somewhere there. It's meaningless. It doesn't matter, it's somewhere there. What I need is this position. So let's do, let's get rid of this frag. I have my word position, component mask. I get, as I explained the previous stream about math essentials, B is basically Z. So X, Y, Z is the same as RGB, it's just a vector. So I take B, which is world Z axis. Let's remap it. Also explained in the previous video. Let's remap it from, and this is important, from my, let's say, dirt start towards dirt end, and this will say the beginning and the end of the gradient in word space in the same terms as here. So if I divided my word position by 100, this will also be in meters because we're now operating in the same space. Basically, by dividing word position, I scaled the space. Okay, just like I would scale UVs. Oh, Starpony, sorry I took this UE5 stuff for so long, but I guess I was pretty excited about it. I wanted to test a lot of stuff, especially that artists are coming to me and saying things like, "Whoa, have you seen this Unreal Engine 5?" Yes, I did. I have to be ready for the questions. Okay, let's start. Don't worry, Starpony, you can rewatch it later. I will also put it on YouTube after one day. So, as I said in previous video, remapping stuff takes a range of values and compresses it to a new range, in this terms to 0 and 1, between 0 and 1. And I have to saturate the results. I forgot about it again. Saturate means clump between 0 and 1. Okay. Perfect. Something's happening here, so I guess we're just higher above the ground than I expected. Let me increase that. Let me do start 3 meters and third and 9. Okay. For the absolute word position, is that for the vertex in word position, or the object word position, or the actor's word position? Even better, it's for the pixels word position. It's visible when I rotate the mesh. Basically, it's the same as vertex because the position between vertices is always a straight line, is linear interpolation. But you can see if I rotate the stuff, can you see that? It's per pixel. Every pixel is a different thing. So yeah, it's per pixel word position. But yeah, position is interpolated, so if you did basically stuff in vertex interpolator with position, it should lead to the same result. But not entirely. Not entirely, because while we're dealing with linear spaces, if it's a linear space, we just divide it, then we just transform the entire space. It's okay. The continuity, the flow is the same. However, if we were to, let's say, put a power to shape this plot, as I mentioned in the previous video, then surely it will be interesting visually, but will look different between vertices and pixels. Here's why. Give me a second. Making power will make it non-linear. So this is no longer a continuous linear space. It gets banded. So this looks cool. This is per pixel, evaluated per pixel. But if I did a vertex interpolator and did it per vertex instead of per pixel for optimization, the shape will change. See? Entirely different. That's because there is not enough vertices to show this new non-linear transition. This is nanite, whatever. Hey nanite, show me triangles. See, there's only so many triangles, so they can't replicate this new custom curve. So doing stuff per vertex with position is cool as long as you don't do anything non-linear to it. Okay, back to pixels. Back to pixels, this is our mask. I want to rotate it. As I said in the previous video, 1 minus x flips the values that are between 0 and 1. And I want to either use this main color or use some other color that I will call the dirt color. And I will do it like this. And also, I will add some noise to it. Basically, be very cautious because noise is super expensive, especially if you have multiple levels. But for me, fast gradient to levels just as a test. And small scale. I will multiply that, make it a little brighter on the output, 0, 5 to 1. Okay. Let's try how the dirt itself looks like. Yeah, Nada doesn't really make it easy for tech artists. There will be many limitations, but we'll have to deal with it. Okay, so this will be our dirt, okay? Our dirt texture. Now, I want to use this mask that we have. Let me show it again. This is this mask that basically, it's too wide. The mask that comes from absolute worst position, then taking only the Z axis and remapping it between 5 and 9 meters to be between 0 and 1. Okay. Actually, this is not needed, this flip. I can delete that and I can just do from 1 to 0. Okay. Like so. And let's use this mask. Let's show it first, how it looks like. That's it. I want to use it to blend, to lerp between the flat color and the dirt. As for the lerp, which is linear interpolation, check the video about MAF in UE5. Okay, like this, come on. So A is my wall paint, B is the dirt. Perfect. And as you can see now, it's based on world position. So when I move the mesh upwards, it gets this texture, this color. Let's make it darker. Right? And when I move it closer to the ground, it gathers the dirt. So this is the very basic use case of world position. Of course, it's not that easy on regular terrain because here we don't know the height to the terrain, but this is a very advanced topic and we should maybe revisit it someday, how to get the distance to the terrain, to the landscape. But in general, everything above 5 meters to 9 meters gets this nice dirt gradient. Perfect. Now, if we want to make it stick to the mesh itself, then what I explained at the beginning. Okay, old siren, give me a second. I will check first this local position stuff. Or instead of using local position, you can just transform world position to local space. Okay. Then the value would have to be different because the mesh has different height, but let's see. Okay, so let's say from 0 to 8 meters? No, but why? It's local position now. I haven't compiled? Sorry. Oh, I did. So what's going on? I transform the vector world position divided 100 and... yeah, it should work. Sorry. Old siren, you're right. I've been transforming from tangent space. Thank you. Now it'd be alright. From world space to local space. Yep. So, world position. Then, what we wanted to do is to transform it to local position. Local position. From world space. This is important. The source. Okay. and remap it, then saturate it. Cool. And dirt start. Dirt, dirt end. Cool. And okay, from we had to divide it to get meters. Divide by 100. As I said before, dividing and multiplying and adding is alright. It doesn't disturb the space. It doesn't damage it. It's still continuous, just scaled or rotated or moved. Dirt start 1 meter and dirt and 5 meters. Okay. And now output range from 1 to 0 and saturate to clamp it. Let's see. I have to put the material on it to this. Okay, cool. Why is it red? Because I only had to take the Z. So component mask and B, which is the same as Z axis, like so. Okay. 500. 5, of course. Yeah, sure. Now I have my dirt. In local space. Okay, Starpony. I hope it will be, first, it will be fast, and second, it will be worth your time. So stay a while, like half an hour. Okay, we have our dirt. Now it's based on local space. So when I'm... It's not. Why? Hold on a second. This division should be done after. I think. Still no? Wait a moment. Transform vector from word to local. What's doing local position stuff? What does it do? It does absolute word position from absolute word space. Absolute word. There's nothing like that. Hold on a second. Where did they get this from? I don't have it. Okay. This is generic transform of the vector, of camera vector, of rotation, of anything. We want specific transform position. Transform position. Sorry, guys. So I messed this up. It should be transform, a specific variant of it. Transform position. From absolute word space to local space. Now it will be okay. But now this end is too high, or? Yeah. So now it sticks to the object. As you can see, the next floors of the building have the same repeated pattern. That's because now it sticks to the object when I transform the absolute position to local space. The same about rotation. It will stay. Okay, cool. There is also something I won't explain here, but you have to know about it. If you're doing a character mesh and it moves, right? You want this position-based effects to be done in the T-pose and then to stick to it. And to do it, there is pre-skinned position. So it returns pre-skinned local position for skeletal meshes. So this is the position in the T-pose of the character, which will stick to it when it moves. Very good, for example, if you want to attach the blood decal made in shader, it has to be in this pre-skinned position, otherwise it will flow when it starts moving. So this is for characters. Okay. And now let me take a look at the notes. Okay, if we're on the topic of position, let's quickly remind how to scale position and how to move position. So we have this very nice gradient. Of course, I can do a RemapRange, it's all right. But what if, for some reason, I didn't want a remap? For example, remap is good for scalars, for z. But what if I, let's say, put a texture based on word position? Let's do a test. I delete all that. I just take my absolute word position. And let's say I want to project a texture on the side. So my word position is a vector. And UVs are a vector too. So nothing prevents me from doing component mask and extracting position to use as UVs. I only take R and G, or no, R and B. So X and Z axis, it will serve as my UV. What will happen if I do a texture parameter? What? Texture sampler parameter? Yes. Text. Okay, let's choose some nice little texture. Can be something abstract, can be wood. I like this wood. I made it, so I like it. And put it into base color. Now, of course, word position, as I said, is in centimeters. So every 1 centimeter, the texture will tile. But let's check. You don't have to believe me. See? Every 1 centimeter, there is a tiling texture. Super small. So, scaling. How to scale? Old Siren, got to go. Thank you a lot for your kind words and see you. Also, thanks for the support during the stream. I'm very glad that you ask questions. Okay, so to scale position, you multiply. So multiply by some, let's say, tiling parameter, 0.01. Multiplication by 0.01 is the same as dividing by 100. So putting it back to meters. As you can see, the tiling is much better now. Okay, I used R and B. I can try G and B, so Y and Z to map from the side. Okay, and now if I move this tiling value, the scale changes. So what I'm doing here is basically I'm scaling the space, the word position space. Normally it's like standard, like every 1 centimeter and so on. I'm just scaling it by multiplying. So multiplying is scaling, while offset is adding. So when you add to a position, either before or after scaling, it just behaves differently. When I add, let's say a vector, and let's call it offset. I add both all R, G, and B, because as I said in previous video, mask, math in shaders happens per component. So R is added to R, G is added to G. So basically, if I want to move it a little up, I will do that. And let's see. So I'm adding to a position, basically moving the position space. Now, this is absolute word position. So when I rotate the object, it stays in place, right? Like so. So this is it. This is how we can use position for something more interesting. So I set up my Unreal to centimeters. No, Unreal is default in centimeters everywhere. If you check word position of an object, It's 11 meters, so 1149 centimeters. But it's good that you ask. It's centimeters. Okay, beautiful projection. However, what if we want a specific shape based on position? Unity is meters, right? What if you want a shape? Let's say that from some point inward, I want to apply some effect. For example, damage. I want to destroy this building in some place. So I keep my texture, it's all right. But what I will add is basically a vector parameter that will be my damage center. Okay, inward space. So let's see how it goes. What I want to do, I want to take my absolute world position in centimeters and calculate a distance from this damage center to the current pixel. So this distance will make a gradient. Very close it will be 0, and further it will be going toward the actual distance in centimeters. Of course, as usual, I want to divide it or multiply it. Whatever. Multiply by a small number. Let's see. Or actually no. I want to again do a remap to make it more easy to tweak. So remap from 0, the actual distance when this is exactly the same spot, to some given end. Let's say gradient end. This end will be 200 centimeters. And I will reverse it again. So I want 1 at the very center, 0 at the outer edge. Okay. And let's check how this mask looks like. Probably there's nothing because our damage center is 0. So I find this position. And it's here. Let's see if it will allow me to copy that. Paste. Okay. So minus 1150, minus 1550, 300. See? My pivot is exactly what I typed as this vector, this damage center, and it calculates the distance from the center to this gradient end. So here is actual distance and here is remapped. Gradient end, I can scale it, and I have my mask. Awesome, right? I have my awesome mask. If I now move this damage center a little, it moves as well. Okay, it's actual world space, so it's 3D, it cuts through the object. If I move the object, you can see what's going on. It's 3D spherical mask. Okay, so now to make it more interesting, I would like to get some noise. Be careful about the noise, it's very expensive, but sometimes it's useful. And I want to do a high flare with this nose. High flare. This is my transition phase, this is my hive texture. And that's it. And alpha is what I want to see. Alpha is the mask treated by this noise. Okay, super cool. As you can see now, maybe it's too strong. Let's make the output higher. Okay, sure. Now the transition is more interesting. In real life examples, use some volumetric texture or something, just a texture to break it down. But noise is fast for prototyping, even though expensive. Okay, so I have my mask. Now I can use it to blend between wood and between, let's say, another texture like damage text. Damage text will be something else. Do I have some burnt wood or no? I don't. Whatever, can be a rock. Can be a rock. Lerp between this and this rock using high flip result. Okay, so as you can see, I have my damage center. I moved that like so, or I move the object and it stays in the same place. The mask stays in the same place. Okay, so this is how we can use a position to get a spherical mask. Now, about the box mask, let me disappoint you because box mask is interesting when it comes to math, but let me just use, out of laziness, box mask 3D. There is A. The default is just the position, word position, can be left default. And B is the damage center. Bounce is the size. So this gradient end, but we're gonna append many to make it 3D. This is the bounce, the size of the box mask. And edge fall off is the smoothness. Smoothness can be small, between 0 and 1 probably. So let's say 0.1. And the result will go into our lerp. So I get rid of this. This is our box mask. Oh, sorry, give me a second to clean this up. Okay, box mask 3D. Takes the damage center as B. Bounce, edge fall. Here it is, our box mask. When I rotate it, you can see how it intersects with the box, like so. Word position based box. And the edge fall off is the smoothness. Let's try 100. Yeah, it's actually in centimeters. So I was mistaken, not 0 to 1, but centimeters. That's it. You can, if you're curious, you can go inside and check the nodes that were used to make this. Not very complicated, actually. Just a couple of, let's say, linear remaps and minimum taken out of them. Okay, so we have our box mask. Give me a moment. Yeah, now, one thing. This is all fluid, right? Fluid math, like continuous space, a gradient. Let's go back to our gradient if we have it. I want to show you how to divide the space into certain blocks. So let's get rid of that. And the textures, they don't matter for now. Okay. Let's take our position and do a frac on it. Okay, this is our position. And let's do it. Is it workspace? Yeah. Why is it flickering? Is he fighting? Ah, we hit the exact 0 when it comes to the axis. Can be problematic sometimes. So as you can see, this is already neatly divided into blocks What if we wanted to do something on a very specific level, let's say the entire level? Then what comes to our rescue is the round node. But round, it's expensive. Instead of round, you might use floor, like this, or ceil. Floor takes the number, the float number, and rounds it down to the lowest integer, the full number. Let's take a look. We have all this. It won't be a super interesting site, but still, let's try. Okay, nothing there. That's because it's either truncate is cheap too, yeah? Truncate, yep, should be the same as floor, basically. Discards the fractional part. So to make it more useful, we should, the floor basically gives us big values still, because it rounds to the full integer. So for example, here, it may be still like full 8, full 9, and so on. So let's divide it further. This time, you remember what happened when we divided the space, right? So this time we divided, but after rounding to the lower integer. And this is what we have, a blocky gradient, like this. I don't know if you can see it through the stream's compression, but basically this is what would happen if we didn't have floor. Smooth transition, continuous space, and this is after floor. Stuff gets rounded to the nearest integers. So we can think about it as cells. Now, why is it useful? It's useful because if you want to, let's say, randomize some features, but for given slices of space, then look what would happen if we do noise, but use, first let's try without it. Let's try without the standard noise, 2 levels, base color, just the original position. This is the noise, right? Now, after this floor, after this division, math is universal, exactly. Exactly. The lessons learned in the previous stuff, previous video still apply. See, every cell after floor has the same value. Every 100 centimeters or so, there will be the same value. So it means that the noise will get the same hash, the same input that drives it. So it can't distinguish, it thinks it's the same thing. Is saturate and clump the same? Will you upload the stream on YouTube? Yes, after 24 hours, because this is what Twitch requires. So yeah, it will be for 7 days on Twitch, and then it will be on YouTube as well. Is saturate and clump the same? In the meaning, yes, saturate is the same as clump between 0 and 1. However, when it comes to code, saturate is basically a free operation, because it's not an operation. It's just a property of the variable. So it gets basically in assembly, in the driver, it gets converted as a modifier, not as a full function. So clump may turn out to be more expensive. Actually though, compilers are very clever, and usually they just convert it to saturate. So no worries, whichever you think is clear. Saturate has a, in theory, higher chance of being a no operation. Okay, so we have our noise applied to cells. What if we wanted to scale the cells somehow? Then we scale the position. Instead of having tiling, let's delete that. And let's add a vector tiling. Now I have control over scale in all 3 axes. So this will be very small, this two, and this will be 0.05, like this. This way I should have vertical slices, right? As you can see, more vertical slices. Maybe I can add more contrast. Okay. Basically, I can now control the tiling in all directions, like this. Here is doing nothing because we crossed the 0 probably, but here it should. Like this. Okay, perfect. So what about it? Imagine that you can basically use the same math, but for object origin to randomize some features. This is not useful. It looks artificial. But let's say, stupid example, but let's say you want to randomize the amount of damage for every object somehow. So here's our damage. We will use the noise again from the word position, like so. Small scale. This will be our damage, okay? Let's just test it as a start. Generic stuff, basically. Nothing interesting. Okay, it applies some damage, right? Some ugly damage. Perfect. Now, what we would like to do is to randomize the intensity of this damage per object, every separate object. So let's say that I don't want this to be fluid. I want lower object to have more damage. I also make it darker to make it more visible. Like so. Okay, cool. I want the bottom object to have more pronounced damage. Also, let me add cheap contrast to this noise. I don't know if cheap contrast is cheap, but just the name, right? 1.5. Okay. Looks bad. Let's add more levels. I don't like it. Okay, enough. Maybe. Okay, so I had this absolute word position, right? But what I want is actual object position word space. Object position word space. Awesome. Now this object position, we can display it for a moment. Yeah, it's actual position of the whole object. It's the basically pivot position of this object in word space. So I'd like to move this. No, it's not. Other. It's not object, not pivot position. Actor position, no. So what's object position then? Actor position word space. Thank you. I wasn't aware. What's the difference basically? When I put this, looks similar. Object position calculate center by bounding box. Oh my. Whoa. That's weird. So object position, I get it. Thanks a ton. So object position is the center of the object in word space, while actor position is the pivot. Jesus. Wow. Okay. So actor position. Thanks a ton. I'm gonna take the component mask of that thing, B, to have Z again. But also, I'm going to use the entire thing to calculate some noise. But this will come later. For now, just the B. And again, remap what you already have, right? From damage start to damage end. Damage end. And 1 to 0 again. Okay. Saturate this. Okay, cool. It will be enough. Now I'm going to, yeah, as you can see, it's not continuous anymore. It's discrete. It's per object, basically. But within this, the whole object, it stays the same. Entire thing black, entire thing gray, entire thing white. Okay. So I'm going to use that to drive, let's say, I know what I can do. I can multiply noise by this. Let's see what it gives us. Yeah, so damage will become weaker. Now I put the result through the chip contrast. So if you have a smooth mask like that, it's good to do multiplications and other like transitions before contrast. Then you can have this nice sharp mask. This contrast, let me add a little, because this is too dark. Not from 0 to 1, but let's say from 0 to 2, and saturate only after the noise. No, like that. Let's see. Do you use preview node view? Yeah, I usually do stuff in the viewport on the actual mesh, but sure, you can right click and start previewing any node to see what's there. But I usually prefer to do it in viewport. It depends, but it's a very cool feature. Okay, so now as you can see, there's an object. It has damage. When I move it, oh, you use it to interview a person. What's the difference between actor position and object position? Awesome. I won't pass this interview, sorry. That's why I'm still here, maybe. I don't know. Can you see? Moving the object changes the property of the noise on the entire object. Because we didn't use word position of pixel, we use actor position of the entire actor. Of course, rotating will do nothing, right? It stays the same, but moving will. Because that's what we used for the mask. Sure, Star Pony. Noted down. I'm also, guys, in general, trying to figure out a way to share the project files somehow. But as you can see, they are changing dynamically as I go. So I think maybe in the future, I will add a button to basically send the current nodes to pastebin.com or somewhere. I have to figure it out when I have some time. If you have ideas, let me know. By the way, small break for commercials. On realtimevfx.com, forums that I really recommend, I've set up a thread for us, basically to be able to leave feedback after the stream and discuss. So yeah, there's a TechArtWay tutorials and live stream thread. And feel free to comment and to say what you are missing here, or what was too fast or skipped. Basically what we like to see. I will put the link in the chat. This is feedback thread. Okay, feel free to talk there. Cool. This is it. Now back to this thing. Let me take a look at the notes. Yeah, we covered floor, ceil, and round. Distance from the player. Let's do this at the end. This is basically the same stuff, but now let's pass player's parameter. Okay, so instead of this damage, we will do some weird shit, like for example glowing stuff, and put it, let's say, I will multiply by this mask. I will put base color where it belongs. And this mask will drive my emissive color multiplied by some color. Okay. Oh, I know what we can do. We can put this entire stuff through multiplying by emission strength and through black body. Oh, this is not emission strength. Emission strength goes here. Black body, I will show you what it does. Emission strength will be 10, but this will be called like temperature scale. Okay, and temperature scale should be 10,000, usually, or less. Basically, black body tries to get you the color of the hot object. So it takes temperature in kelvins and gives you the color through red, orange, yellow, white. But I've done something very wrong. 5,000. 1,000? I don't remember. It's very weird. 500, but very bright. Cool. Awesome. Okay, so let's say this is a fire. Let's say. Imagine that. Okay, looks like a fire. Awesome. Now we'll add this burning around an object. So actually, let's place an object. This could be our object maybe, or let's add a new one. Let's add a ghost. Perfect ghost. Here it is. Now this ghost will have a different material to be visible. Maybe this neon ghost. Ah, perfect. Okay. And let's make a blueprint out of it in essentials, new folder temp, and let's call it BP burning ghost. Okay. Burning ghost. This is a ghost. Now, let's create a material property, a material parameter collection, MPC, let's say fire global. This is a way to pass material parameters globally to every material in the world, if you choose so. So I have a video about it. It's on YouTube. It's interactive materials. Date. Yeah, it's this one. You can check it out, but in general, vector parameters, and this will be ghost position. Okay, defaults to 0. It's okay. And now this ghost, when it moves, every tick, it will Or not every tick, because other will kill me on the chat. Let's do an event, custom event, and let's say ghost move. Okay, and let's make a timer. Set timer by event every 1/30th of a second, so 30 times per second. Huh. See, other, I did it right. Looping, and okay, it makes it that every 1/30th of a second this will happen. And what will happen? Basically, it will be set vector parameter, collection npc fire global, parameter name ghost position, and it will take actor position, no, actor location. Get actor location. Let's break it down. This two. Basically, actor location will be sent to materials. Okay? That's it. Now, in my material. Yeah, exactly. Every tick strains the CPU. 1/30th of a second may be enough. And now, instead of this vector that we have, this damage position vector, we used a remapped position of actor. Let's do again the spherical mask. So, get rid of this. Or no, this is useful. Let's get rid of this. Now, what I want to move through, so instead of damage end, it will be like damage radius this time. 800 centimeters from the ghost. Input will be distance from word position of the pixel to parameter collection fire global ghost position. Okay, this is float 4, so we have to do component mask on it, RGB without A, so XYZ. Okay, we compare the distance between those 2 points and remap it to a shape. Let's try to apply. Of course, the ghost is doing nothing now because we're not in a game, but when we play the game, it still does nothing. What? Or maybe the event isn't starting? Okay. Jesus, I set the timer every tick. There goes my optimization. Okay. Here I set the timer now at the beginning of the game. Yay! See? Stuff begins to burn when the ghost walks inside. There it goes. And that's it, guys. Our weird example is working. Thanks, Slider. So this is basically how you can now attach it to a player, right? And just begin making more advanced effects out of it. Okay, that's it for today. Thank you for this very long session. Sorry for the crashes. And I guess we're one of the first ones to test UE5's limitations. Thanks for being here. See you next time. Cheers.